Hello, Namaskara. Today we are going to study the continuation of basic plots. In the last class, we have studied the mathematical functions used in circuit simulation lab as well as how to draw the basic plots. Now we'll see the continuation of basic plots where we can draw multiple plots in a single window as well as other type of functions in circuit simulation lab. So in this today we are going to study multiple data sets in one plot, specifying line styles and colors, copy and paste the figures. So this can be done with the examples only. Now the pairs of multiple graphs is given by an example where y1 is equal to 2 cos x, y2 is equal to cos x, and y3 is equal to 0.5 cos x with an interval of 0 to 2 pi where we have variation of x in between them. So for this we have a program like this. So this program I will take into the MATLAB. Then I will explain each and every line here. Now I will take the M file. Same thing I will copy this one to MATLAB. Run the program. So you see the graph. We'll get the graph like this. So now I will explain how we will get this type of graph. So first of all, I will go with the programming. Here x is equal to 0 is to pi by 100 is to 2 into pi. That means as you know it is varies from x is varying from 0 to 2 pi here. So this is similar to for statement in C language where the first component or the first element will be the beginning, second element will be usually it will be ending, and the third element is increment. But in this case here the first element will be the first component will be initialization and last component will be final component, and in the middle actually in C in the middle it will be end, but here it is the increment. Here it is pi by 100 I have written. So if I change this one to pi by 1000, what happens just we'll see. Just I'll run the program now and you can see what happens. So we are not observing anything here. Now I'll change the values of the increment now again. just I will decrement this one, say it is pi by 2 I will take. Now again I will run the program. Now see what happens to the figure. So it is having this type of figure. That means the increment is very less, so it will be shown like this. Similarly, if I change the values, say it is 2 to 5 now. So 5 means, how you see the figure? So just you see here, this is like this. So almost 5 points will be in this figure. So like this, the increment can be given at any type, but if you give the many in, points of increment, then the graph will be very good. Therefore, I am taking, say it is 5 by 100. Now I will run this one. Now you see the graph like this. Similarly, if you go 1000, no problem. So you will get even this part. This is the first part. In this, as you know, y1 is we have some value here, y2 and y3, but it can be differentiated by this type of figure here. That means in the equation itself, if you write type of line, that is dash dash, means here we can observe the figure. So here we can get the dash dash line. That is nothing but we can say it is y1 now. Similarly, if you go for y2, I have taken dash, and for y3 I have taken dot here. So like this it can be, we have so many types where we can write plot x comma y 1 comma in the single apostrophe dash dash, x comma y2 it is single apostrophe dash, and in x comma y3 it is dot. So that can be identified here in the graph. So that is nothing but here we can see that is the dash dash dot dot as well as the double dash. Now we label the part, label the graph. So first x label. So x label, as you know, in the last class we have studied, x label is equal to, sorry, x label in the single apostrophe. So just I will see what I have written in the this part only, I will mention as it is. X label is 0 dash less than or equal to x less than or equal to 2 pi here. So x level is like that. Y level is cosine function. So because we have taken all cos, then cosine function. So x level will be like this. So I will write similarly 0 less than or equal to x less than or equal to 2 by single apostrophe. So I'll run the program now. So we'll see the graph. So here I have taken that one. So 0 less than or equal to x less than or equal to 2 pi. Similarly, for y coordinate, so y axis, y level, so it is a cosine function. So this is again, I have run the program. I will see the y-axis, that is cosine function. Now I will go with the other part. So in this part, legend is the another command here. So legend is 2 cos x is the y1, comma cos x is the y2, and cos x 0.5 cos x is the y3. So what is meant by legend? We'll see the program itself. So in this part, I will write legend now. Single apostrophe, it is 2 cos x, close the bracket, comma, cos x is maybe 2 cos x, comma, second one is cos x, so it must be under the single apostrophe, comma, single apostrophe 0.5 into cos x. Now I'll run the program. So I'll just see what happens to the graph here. Just you see here, now it will indicate which is y1, which is y2, and which is y3 now. So the single double dash is nothing but 2 cos x, that is nothing but y1. Next it is single dash, that is cos x, y2, and is the dotted line, that is y3. So this is the another type where we have to write. In important thing is here y1 means you have to write the first thing, y2 for the same thing, and y3 for same thing. If you interchange it, it automatically changes. Therefore the equation which is y1 y2 y3 means here also it must be y1 y2 and y3. After this, another important command is title. So this is title is given as typical example of multiple plots. So typical example of multiple plots is the title here. So title is given as single opposite typical example for multiple plots. So I'll run this program so we can see the graph is a typical example for multiple plots now. Then the important thing here it is the axis. Now you can see here the axis of y is from -2 to 2. Similarly for the x-axis it is from 0 to 7 now. So 0 to 7 as well as the it is from -2 to minus. We can change the axis also. So axis can be changed with the command here like this. So now the command for axis is 0 to 2 pi, that is nothing but here its x-axis is 0 and the final will be 2 pi, and here y-axis starting from -3 and it will be 3 here. The important thing is here we have what is called a square bracket, as well as we have a bracket here. Now I will show it is in the program. So in the program I will write axis, it is single apostrophe, sorry, square bracket, then it is 0, I'll 2 pi, next it is -3 and 3. Now you can see in the graph the coordinates is changed now. It is from, it is not changed, just I'll run the program. It is now, you see it is -3 to -3 y-axis, 0 to 2 pi, that is nothing but I have to write in the other format. So then we can see in the 2 pi also, that is like this. This 2 pi should be in slash here, so that can be seen here, or otherwise I can give the values also. Just I will give the values. Now it is 7, just I will give the values like 6 and I will run the program. You can see it starts from 0 to 6 here. So this is another command used in a graph here. These are the commands used and the multiple plots drawn in a single window. So next part is, so you can see here, this is the legend, this is the title, this is the y-axis label, and this x-axis label. Like this we have. Next it is specifying line styles. So we have different types here for the lines. So we can have a color change, as well as we can have a different types of lines here. So this can be done with the this table. Now not to change the color, K is for the black, R is for the red, B is for the blue, G is for the green, C for cyan, M for magenta, and Y for yellow. Similarly, this is the solid line, this is the dashed line we are used now, this is dotted line used now, and dash dot, and no line. No line default means it is continuous line here. Similarly, we can have a plus sign, circle, asterisk, point, cross, yes, that means D, where we can see in the points also. That means if you take the graph here, where we have points, so we can mention the points also in this part. So that can be done, and we can change the particular part here. So I can change now. Say I have taken this one. So I will take this here, it is dot dot, and here I will take it as dash dash. Now if I run the program, so we can observe. So in this case, see here, now the red color will be dash dash, and this is y1 will be dot dot. Similarly, we can change the color also. So in the previous classes, previous class I have given under the single apostrophe, if I write R, the color will be changed. So this is the part where we can have different type of or multiple graphs which is drawn in the particular window. Now specifying the color and size of the markers, you can also specify the line character using graphics properties. So here this is the next part of the graph where we can have line width, we can have the marker edge color, marker face color, marker size. So this can be done in the next part where here we have what is called as marker edge, marker face and marker size also. So this is the another example where we have it is minus pi to pi. So the same thing I will take and I will change the particular part here. So that can be observed in the graph. So first I will take this part, I will remove this one. Now I will take this. Where I have taken this part now. And I will copy this one too. AtLab. I will save this one and I will run. Now I've got this type of graph. Now here these are the points where we have different points. Now we can change the size of the points also. I will take this one here. Now this is the color is border color. So we'll make it as now red. So by writing red here, just observe this one. So now the outer edge color will be red. This part is red now. Now it is in green now. So I will make it as black. So that can be done by writing instead of G, I will write black here. Now I can go with some other color, say it is blue. So now I'll run this one. You'll see the color will be changed. It will be blue now. Similarly, the size of these points. So these are the points where we have in the graph. So that the graph points will be increased by pi by 10 here. It is minus pi to pi. So this one is point. So size I have write is 100 is too much actually, but I will write this one and see how the graph will be. Now the graph will be like this. These points will be observed. So if I write very less, that is I can say it is 20 now or 30, then you can observe the difference here. Now I will write only 20 instead of 10. Run this. So I will see the size of this one is like this. It is increased now. So like this you can write with these some functions, commands. We can have so many types in the particular simulation lab. So now we can improve this one with different types of programming. So this is the thing where we have in the plotting of the graph. So we can write different types and we can change the points, we can change the what is called as axis. Everything can be done here. Next is copy and paste the figures. Figures can be pasted into other apps. So Word and this is very easy. So just in the edit we have what is called as copy. So then we can see here it is the edit. We have a copy figure. So in this copy figure we can copy into the any part here. That is the thing in this part. So here also we can have some changing font size, changing properties can be done. We can write in the PPT also. So it is done in the any format. That means copy and paste is done very easily. So here also we can have some sort of printing part, so that can be done here. Then you can have in the form of waveform like this. So these are the some of the commands used to know this one. So saving the figure, so saving is nothing but where we can have figures can be saved here in many formats. The common one is nothing but it is in the JPEG format, so it can be done, BMP format, or it can be changed in the form of PDF also we can save. So by save as, you can give here, then it can be done in the other formats also. So here we have save as, so save as, then we can give in the any format here. So it will be MATLAB figure. So also we can change in the whichever format you want, we can save it. So that is the thing in the particular part here. So this is the HL unit where we can or we have studied the drawing the basic plot as well as the multiple plots. So now we have multiple choice questions. So multiple choice questions in this, what are the commands which are not used actually in these examples, but we have many type of examples where we have many functions which will be used for the writing the program. Now this is a simple one. A student has created a plot y of t is equal to t2. He need to show another graph j of t in t3 in the same plot. But every time he hits the plot function, MATLAB generates the plot at the different window. What is the error? So here, this type of axis where we have in the given example, directly we can write in the same window. But if we have the different scale as well as the different types of equations, then we have to use one more command. So that is, I will see here, it is not the possible to plot the multiple plots. He is not using the line function, maybe using stem, or instead of plot, is not using the hold function. So that is, here the answer is D. The hold command is used to hold the cursor, developed after creating the plot, so that the next graph when plotted will appear in the same window where the initial graph was plotted. So this is the one important command. Similarly, what is the difference between hold on and hold all? So is there any difference? No difference. Hold solved does not exist. Hold on is syntactically incorrect. The answer is A. Both hold on and hold all commands are used in hold the graph of a function. There is no difference between them. Third one is to place a text on the plot using mouse. The command used. So gtext, text, title are the A text. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೀವು ಮೌಸ್ ಮೂಲಕ ಅಲ್ಲಿಗೆ ಹೋಗಿ ನೀವು ಕಮಾಂಡ್ ಉಪಯೋಗಿಸೋದು ಯಾವುದು ಅಂತ, ಇಟ್ ಈಸ್ ಎ, ಇಟ್ ಈಸ್ ಜಿ ಟೆಕ್ಸ್ಟ್. So gtext is the command. This is a predefined function of MATLAB. If you want to place a text at a position of our interest in the graph, we need to use gtext command. Next is which command enables the title of the axis. So x axis ಅಲ್ಲಿ ನಾನು ಹೇಳ್ತಾ ಬಂದೆ ಯಾವ್ದನ್ನ ಉಪಯೋಗಿಸಬೇಕು ಅಂತ, ಇದೆಲ್ಲ ಗೊತ್ತಾಗಿದೆ ನಿಮಗೆ. So answer is A. The X label command is used to include the title, signify the X axis in the graph plotted in the MATLAB. Hence, only correct option is X label in the bracket symbol of first of all you put. Similarly, what the command enables the title for the y-axis. So y-axis ಅಲ್ಲಿ ನೀವು ಇದು ಯಾರನ್ನ ಉಪಯೋಗಿಸ್ತೀರಾ ಅಂತ A B C D ಇದೆ. So B is the command used here, y label. So for the axis of the graph plotted in the MATLAB, hence option y label is correct. The period of sinusoidal curves can be changed in MATLAB, true or false. So ನಿಮಗೆ ಗೊತ್ತಿರಂಗೆ answer is true. The sign of the command is defined to generate the sinusoidal with the fundamental time period of 2 pi. The period of sign can be changed by changing the angular frequency while giving the input to the sine command. Which command can be used to generate multiple graphs in the same window? So again, it is a repetitive question. Hold on, wait, not possible without counter command, not possible. Answer is A. Answer is A is hold on. So the command used to hold the control of the already generated graph so that the further plots can be made on this same window is hold on. So counter command is used to generate the graph of the same function on different levels, while the hold on command is used to generate the graphs of multiple functions in the same window. So counter command is different to the hold on. The default color of the graph can be generated. The plot command is blue. So ನಿಮಗೆ ಗೊತ್ತಿದೆ default ನಾನು last class ಅಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. It is true itself. The default color is graph is generated by the plots. The stem command is blue. It can be changed from the plot command itself or the set the command. So ನೀವು ಅದು ಫಸ್ಟ್ ಆಫ್ ಇಲ್ ಸಿಂಗಲ್ ಫಸ್ಟ್ ಆಫ್ ಇಲ್ ಹಾಕಿದಾಗ ನಿಮಗೆ ಬೇರೆ ಬೇರೆ ಕಲರ್ ಬರ್ತಾ ಹೋಗ್ಬೋದು. ಸೊ this is the end of the second session of mathematical functions. So I hope you understand everything. So by practice or we have number of problems, then we can easily understand these commands here. Thank you.